No one, absolutely no one, has ever successfully developed a fully reusable orbital heat shield. Sounds impossible already, doesn't it? But that's exactly one of the ultimate bosses SpaceX is up against on its journey to conquer Mars. Elon Musk, a man who's never afraid of impossible challenges, has admitted it himself. Perfecting this system may be nearly impossible. But what exactly makes it so hard? It's not just about creating a shield strong enough to protect the crew and valuable cargo. It's about building one that can endure thousands of atmospheric re-entries, the very thing Musk's Mars settlement plan demands. Can you picture it? A fragile ceramic tile surviving an inferno of fire and plasma, over and over again. So what exactly is Musk up against? And how will SpaceX overcome this life-or-death barrier? Welcome to space. Now, where we dive into the secrets behind today's most groundbreaking technologies. Did you know Earth gets bombarded by thousands of tiny meteoroids every single day? Most are only the size of a grape and burn up in the atmosphere like fireworks. And the bigger ones about the size of a basketball or even a small car. Now imagine a spacecraft returning to Earth with no heat shield. It would be torn apart just like one of those meteoroids. That's why thermal protection is one of the most difficult challenges in aerospace engineering. From the Space Shuttle to Dragon, every spacecraft owes its survival to a cutting-edge heat shield. Even Elon Musk, who successfully developed the Pika-X ceramic shield for the Dragon capsule, is still struggling with this issue when it comes to Starship. On paper, the ceramic tiles on Starship's surface seem to be performing quite well. After Flight 9, Elon posted on X Starship reached the planned engine cutoff, a huge improvement over the previous flight. No significant loss of heat shield tiles during ascent. That sounds promising, but the bigger picture is far more complex. In a May 29th update, Elon, for the first time, took a deep dive into the heat shield issue while discussing his plans to send humans to Mars. SpaceX's long-term goal is to develop a single heat shield system that works for both Earth and Mars re-entry. If successful, they could carry out hundreds of test flights on Earth, collecting valuable data before sending humans on a 62-million-mile journey to the Red Planet. Sounds logical? Maybe. But, in reality, it's far from easy. Earth's and Mars' atmospheres are as different as fire and water. Earth's is dense, rich in nitrogen and oxygen. Mars. It's over 100 times thinner and made almost entirely of carbon dioxide. This difference drastically changes the pressure and heat during re-entry. And that's where the real challenge begins. A Starship re-entering from low Earth orbit can reach speeds of 4.3 to 5 miles per second, facing temperatures as high as 5,400 degrees, still within reach for current materials. But Mars plays dirty in a very different way. While the atmosphere is thinner, CO2 turns vicious when heated into plasma. It breaks apart into highly reactive free oxygen atoms, the kind that eats through almost anything, including heat-resistant materials. Under those conditions, a shield that seems strong enough for Earth might fall apart, like ice under fire, when entering Mars's atmosphere. Hold on. You thought the heat shield was the hard part. That's just the warm-up. An entire in-space refueling system is coming up, and it's going to blow your mind. Stay tuned right here on Space Now. Elon made it clear, if you don't test under the right conditions, you're never truly prepared. What do you think? If you were an engineer at SpaceX, how would you simulate Martian conditions right here on Earth? To highlight this danger, Elon released a test video showing a plasma torch hitting one of Starship's heat shield tiles. At first, the surface glows bright red. Then it scorches blisters and begins to crack. A brutal test, but a necessary one. Because if you don't push these materials to the edge, the line between success and catastrophic failure could just be a gust of flame in space. Want to see what happens next? Don't forget to leave a comment below. What do you think is the biggest challenge SpaceX has to overcome to make the Mars dream come true? If that kind of damage ever occurred during an actual atmospheric re-entry, the result could be total mission failure. This isn't just about surviving the trip back to Earth. It's a life-or-death trial for anyone dreaming of Mars. Because out there are no second chances, no rescue teams, no orbital repair stations, one small failure, and it's game over. Sounds harsh, it is. But this isn't the first time humanity has faced the brutal challenge of protecting a spacecraft from the fury of re-entry. The Apollo missions used Avcoat and epoxy resin composite filled with silica beads to bring astronauts safely back from the Moon. SpaceX's Dragon capsule uses PISA-X, an optimized version for Earth's atmosphere. Impressive, maybe. But those achievements were built on decades of trial and error in familiar environmental conditions. What about Mars? That's an entirely uncharted frontier. No crewed spacecraft has ever attempted atmospheric re-entry on the Red Planet. That's why the work SpaceX is doing now is absolutely critical. Every Earth-based test is just a first step. The real challenge will begin when Starship punches through the thin, frigid, oxygen-rich atmosphere of Mars, a place where everything is working against you. To make it happen, SpaceX is pushing the boundaries of materials, science, aerodynamics, and thermal protection engineering all at once. There's no safety net left. Every test flight lays another brick on the path toward building a heat shield that can not only survive Earth, but withstand the hellish descent into Mars. And for Elon Musk, surviving re-entry isn't enough. He wants a system that's fully reusable, able to fly again and again without the need for replacement after every mission. Did you know even NASA's space shuttle never truly achieved this? While its thermal protection system was technically reusable after every flight, it took months to inspect and repair nearly 24,000 fragile ceramic tiles. It was a nightmare in terms of cost, time, and manpower. Why is this so hard? Because a re-entering spacecraft faces scorching heat, crushing pressure, and extreme vibrations, conditions only advanced materials like glass ceramics, carbon-carbon composites, or heat-resistant alloys can endure. Even then, these materials degrade over time, cracking, spalling, and eroding are inevitable. Still, Elon is determined to make SpaceX the first company to build a fully reusable orbital heat shield. He said, "This doesn't break any laws of physics. It's just a brutally tough materials engineering problem." And that's going to be one of SpaceX's top priorities in the coming years. Do you believe it's possible? Hints of SpaceX's new strategy started to emerge after Starship's 9th flight. They began experimenting with replacing some of the ceramic tiles with metal panels, likely stainless steel, using a technique called film cooling, or more vividly, sweating. Sounds crazy, right? But SpaceX is actually working to turn sweating into a revolutionary technology for spacecraft. Hard to believe space now is here to break it all down for you. Basically, a small amount of cryogenic fluid like liquid oxygen or methane flows through microscopic pores in the surface of a metal panel. As it seeps out, it carries heat away, just like how the human body cools itself by sweating. This method could be a game-changer compared to brittle ceramic tiles that easily crack under intense vibrations during launch, or re-entry metal can absorb and withstand these forces far better. In addition, metal offers much greater resistance to thermal fatigue, the destructive stress caused by repeated expansion and contraction. With every re-entry, a spacecraft endures massive thermal cycling, causing ceramic to crack, peel, and degrade over time. But if this sweating metal system works as expected, it won't just regulate heat more evenly, it could drastically reduce repair time between flights. That's a crucial factor if we want to run a fleet of starships between Earth and Mars, like an interplanetary bus service. In theory, this could revolutionize how humanity approaches thermal protection in space missions. So what do you think about this strategy of using sweating metal shields instead of traditional ceramics? Could this be the key for Starship to reach the level of reusability that Elon Musk dreams of? Instead of replacing thousands of ceramic tiles after every flight, SpaceX engineers are aiming for a much simpler future. Just inspect a few fluid-cooled metal panels, refill the coolant, and launch again in a matter of days. A process more like fighter jet maintenance, fast, clean, and efficient. But of course, no technological breakthrough comes without a price. Film cooling this sweating method requires an extremely precise fluid delivery system. Even a single blockage or inconsistent flow can create dangerous hotspots areas where temperatures spike beyond safe limits and could burn through the heat shield. To prove its effectiveness, SpaceX must run a wide range of tests from lab simulations on Earth to harsh conditions in orbit. Still, Elon Musk remains confident. Based on what SpaceX has already achieved from landing rockets to reusing boosters, no one dares underestimate their ability to turn the impossible into reality. If they succeed in making this heat shield reliable for Earth re-entry and adapt it for the oxygen-rich plasma environment of Mars, then the milestone of a truly reusable interplanetary spacecraft will no longer be science fiction. Make no mistake, developing a reusable heat shield isn't just a technical victory, it's the foundation for a multi-planet future. And that's why SpaceX is so committed to solving what once seemed like an unsolvable problem. But this is only the beginning. To reach the dream of Mars, the next step is in-space refueling. Imagine mid-air refueling, but this time it's between two starships orbiting Earth. Sounds bold, but in theory, it's entirely possible. Two starships would rendezvous in low Earth orbit. One acts as a tanker, transferring fuel, primarily liquid oxygen, which accounts for about 80% of the total mass, with the rest being methane to the other. The Mars-bound Starship would be launched nearly empty, then receive fuel from multiple tanker flights. Once fully refueled, it would leave Earth orbit and head toward Mars or the Moon. Musk once shared that an orbital refueling test could happen as early as next year. However, fuel leak issues in the Starship V2 prototype might cause a slight delay. Despite setbacks, Elon remains firm in his philosophy, go slow to go far. Rushing complex systems has never been the smart move. But once orbital refueling becomes a reality, the gateway to sending massive payloads beyond Earth will finally open something that until now belonged only in science fiction. Still, refueling alone isn't enough. Musk's bigger goal isn't just to send a few astronauts to Mars, it's to build a fully self-sustaining civilization. That means transporting an entire ecosystem, life support systems, habitats, solar panels, mining equipment, agriculture, and even manufacturing tools. To do that, Starship must evolve. Enter Starship V3, also known as Block 3. This will be the most significant upgrade, yet bigger, more powerful, and 100% reusable. Key improvements include reinforced interstage structures to enable hot staging, where the upper stage ignites its engines, while the booster is still firing, maximizing performance without destroying the vehicle. In terms of size, the full version of Starship V3 could reach 466 feet. Prototypes like Booster 18 and Ship 39 currently stand around 407 feet tall. The added height comes mostly from expanded propellant tanks, allowing up to 8.8 million pounds of liquid fuel. Thrust will also see a dramatic increase. Early V3 versions may reach 18.3 million pounds, eventually climbing to 22 million, a staggering figure by any standard today. With that kind of power, Starship could deliver 2.2 billion pounds of cargo to Mars, enough to lay the foundation for a self-sufficient colony. Elon estimates that it would take around 22 billion pounds of materials to build a truly autonomous society. At that point, Mars could sustain itself even if supply lines from Earth were cut off. Another critical factor is landing site selection. Elon has mentioned Arcadia Planitia, a flat ice-rich region in Mars's mid-latitudes. It offers stable temperatures, smooth terrain, and most importantly, access to subsurface water, an essential resource for early colonization. But before those dreams can take shape, two major engineering challenges still loom: mastering orbital refueling and perfecting a reusable heat shield. And SpaceX is racing to solve both simultaneously through suborbital and orbital test flights. Each successful launch brings us one step closer to an interplanetary future. If they succeed, launching thousands of tons of equipment and people to Mars every 26 months when the launch window opens will no longer be a fantasy. And once the first shipment, the first 2.2 billion pounds, touches down on Mars, humanity's path toward becoming a multiplanetary species will officially begin. This is the big picture, one of the most ambitious undertakings in human history, turning the dream of Mars into reality. From sweating heat shields to in-space refueling to building a starship that can carry an entire civilization. Everything we've just explored is not just about engineering, it's about willpower and a vision that dares to reach beyond the limits of our blue planet. So, what do you think? Does SpaceX truly have what it takes to turn science fiction into fact? Or is this still the bold gamble of a risk-loving billionaire? Drop your thoughts in the comments. Space Now always wants to hear from you. What's your take on this mission? Leave a comment, share your perspective, and join thousands of viewers at Space Now as we write the next chapter of space exploration together.